AP review. This is 2014 AB FR6. Consider the differential equation dy dx equals the quantity 3 minus y times the cosine x. Let y equals f of x be the particular solution to this differential equation with the initial condition f of 0 equals 1. The function f is defined for all real numbers. Okay, so please excuse my terrible recreation of the slope field. I was just not about to do it. So you're given a pretty good slope field on the actual AP, and then you're asked to draw on it, which is fine, but recreating that slope field is horrible, so you're just going to have to use my crappy picture instead. So here's my crappy version of this slope field. Sketch the solution through 0, 1, which I'm going to do, but again, terrible. So you're going to drop a leaf in the water at 0, 1. Right? And then you're going to follow the slant of the curve, right? So you're going to follow each little snippet of slope up until it, like, you'll see it starting to level out right around like 1.5, and then it levels out and it turns back down, right? And you follow the slopes, so one little snippet of slope to the next one, right? And again, you can't really use my graph as a way to do this, and it's a little bit steeper on this side in the real graph, and then it's going to get to the middle where you'll see them starting to level out. You can kind of see how they turn the other direction. And then it's going to work its way back up like this. Again, that's a very bad version, but I did not have the fortitude to resketch this horrible slope field, so forgive me. And that's it for part A. They just want you to sketch the solutions curve. And I'm going to erase it because that's horrifying and frustrating. Cool. Part B. Before we do much else, I can point out that this is separable, so there's a good chance, like a very, very high chance, that they're going to make you separate this and solve this for either part B or part C for almost all of the points, which is totally what happens. But so part B does not make you solve. They say write an equation for the tangent line to the solution in part A, which is 0, 1, and use the equation to approximate f of 0.2. Okay, so remember, anytime you need an equation of a line, you need two things, right? You're always going to need, 1, a point. Well, conveniently, they gave us 1 at 0, 1. And 2, you're going to need a slope. Well, in this case, you have a slope because you know dy dx, and you just need to evaluate it at 0, 1, right? So when you do that, you're going to get 3 minus 1 times the cosine of 0, which is a 2 times a 1. So you get a slope of 2, right? So what ends up happening is you get that your equation is y minus the y value equals mx minus the x value, right? And you can leave your answer like that. If you want to add the 1 over, you can. If you want to go ahead and make this just a 2x, that's fine. You can write it as a 2x plus 1. Just be mindful that if you do something silly, it's on you. And then they ask you to use it to approximate f of 0.2, which would be 2 times a 0.2 plus a 1, so 1.4, right? F of 0.2 is approximately 1.4. Cool. And that actually is an equal sign. This guy's approximate. Okay, cool. Part C, for all of the big bucks, find y equals f of x, the particular solution to the differential equation. So this is going to be worth, on average, 5 or 6 points when they ask you to do this part of a diffie-q problem, right? So the first thing I have to do is, and I'm just going to move my f of 0 is 1 over here. I need to divide this y stuff over and multiply this dx over. So I'm going to end up with a dy over 3 minus y equals a cosine of x dx. Sorry, said it, didn't write it. Okay, so you get nothing if you don't separate the variables. So notice that all of my x stuff is on the right-hand side with dx, and all of my y stuff is on the left-hand side with dy. The d stuff has to be on top of the fraction. Cool. So separate your variables first. Next thing you need to do is do the antiderivative for both of these. These are generally pretty easy antiderivatives, so nobody thinks you're cheating if you're doing it in your head. If you do this natural log, because it is a natural log, notice that your u technically, if you're doing u sub, it has a negative in it, right? So your u would be 3 minus y, which means that your du would have a negative. So when you integrate this, you're going to get the negative natural log of the absolute value of 3 minus y. So just be on the lookout for that negative. On the other side, when you integrate cosine, you get sine of x plus c. You only put the constant of integration on the side with the x because you're going to have to solve for y anyway, so you'd have to move all the constants over anyway. And also, you only have 1 point to plug in, so you don't have enough points to plug in and find two different c's, like a c sub 1 on the left and a c sub 1 on the right. You'd combine them all on the right as one c. You now have a choice. You can either, so there's two things left to do, right? So at this moment, right, there are two things left to do. One, I need to solve for y. And two, I need to plug in to find c. It doesn't matter which one you do first. It's mostly a style preference. So I'm going to go ahead and find c first, but it really doesn't matter which one you do first. So when I plug in, I get negative natural log of, this is going to be a 3 minus a 1, so it's a 2, right, equals sine of 0, well, that's convenient, plus c. So I just get negative natural log of 2 is my c, because the sine of 0 is 0. So great, I get a negative natural log of 2. So now I need to go ahead and take this information and take this thing and make it look a lot nicer and solve for y. So I'm going to erase this stuff up here so I have a little bit of space, and I'm going to copy what I have. I now have the negative natural log of the absolute value of 3 minus y equals sine of x minus a natural log of 2. Cool. All right, so now we're going to solve for y, which was the last thing that we have to do. So I'm going to go ahead and divide everybody by a negative, so I'm going to get the natural log of this 3 minus y equals, and what's going to happen is I'm going to end up getting a negative sine of x plus a natural log of 2, right? And then I'm going to exponentiate, right? So when I exponentiate, I'm going to go ahead and do this, right? So I'm going to get this absolute value of 3 minus y. We're going to talk about this in a sec. I'll explain to you in a sec why I'm going to get rid of that absolute value, right? Plus this. Okay, so what I want you to notice is that you have to be careful if you do it this way. Because I know that I'm looking at y values, so I know that at the point in question, right, I know at the point in question that this netted positive without the absolute value. So what's going to happen is I know that I'm okay to not need the absolute value for this exact curve because the y value I'm using is making this thing net positive. So essentially I don't need the absolute value, so I can write this. Now I'm going to show you another way to do this in a minute if you prefer. It doesn't matter to me which one you pick. Interestingly enough, and you can leave it like this if you want, there is a way to clean this up. So the other way to clean this up is if you want, you can write this side as e to the negative sine x times e to the natural log of 2. And the reason I say that is because you can cancel e to the natural log of 2 and make it just a 2. So this would be 3 minus y equals 2 e to the negative sine x. And that's the other way you'll often see it if you had gone the other route and solved for y first and found a different c. I'm then going to subtract the 3 over, so I get negative y equals 2 e to the negative sine x minus 3, and then I divide everybody by a negative, and I get that y is negative 2 e to the negative sine x plus a 3. And that's my answer. Just a side note, so the reason I knew I didn't have to worry about getting rid of the absolute value again is because the y values I'm choosing here would net it positive anyway. There is another way to do this, and I'm just going to walk you through. Let's say you had made the opposite choice, okay? Let's say that at this moment, you had decided to solve for c, right? And again, you're going to decide which thing you're more comfortable with. So let's say at this moment you decided, not solve for c, you decided to solve for y. So if you chose to do that, the first thing you do is divide everybody by a negative, right? So you'd get the natural log of the absolute value of 3 minus y equals a negative sine of x, and it doesn't matter to me if you call it plus or minus. I'm just going to call it plus c sub 1, because when I divide c by a negative, it just gets a different c, so it's c sub 1. Then I could exponentiate, right? And if I do that, I'm going to get that this is 3 minus y, and I'm going to go ahead and get rid of the absolute value, because I'm going to use that shortcut that I talked about a second ago with the natural log to recognize that e to the negative sine of x plus a c sub 1 is the same as e to the negative sine of x times e to the c sub 1, which I could just call a new constant. So I'm going to say that equals c sub 2 e to the negative sine of x. And here's the reason I just dropped the absolute value without even thinking about it. The fact that I made this e to the c sub 1 into a different constant, technically e to a power should come out positive, but e to the c sub 1, which should come out positive, I just renamed it a new constant called c sub 2, and I don't know the sign of c sub 2 actually, so that kind of absorbs the issue or the concern I would have about whether this absolute value needs to have a negative in front of it or not, because it doesn't matter, because it's going to land with the right coefficient now with whatever c sub 2 is. If I go to solve, I'm going to subtract the 3 over, or honestly, you could just move this guy over and move this guy back. It doesn't matter. But I'm going to subtract the 3, so I'm going to get y equals c sub 2 e to the negative sine of x minus 3, and then divide everybody by negative. So I'm going to get y equals, and I'm just going to call this c sub 3, right? E to the negative sine of x plus a 3, right? And so now I can find this c sub 3. The thing to notice is that I'm not ever actually finding this c that I started with. I'm finding a new constant that's been manipulated a bunch of times. And so to find that, I would plug in the f of 0 equals 1, and I'd say 1 equals c sub 3 e to the 0 plus 3, negative 2 is my c sub 3, and you'll notice that I get negative 2 e to the negative sine x plus 3, which is the same answer we got the other way. So again, it's sort of a style preference. If when I switched all these constants out, you're like, Hogan, whoa, what's happening? I can't handle this. Well, then maybe this isn't the option for you. And that's totally fine.